Okay, so in previous class, you must have learned about 2D geometry. Okay, there we are talking about the two-dimensional 2D geometry where the coordinate will be in the form of like x comma y. Okay, two dimension, two measurement will be there. Here we are going to talk about 3D geometry. So here the coordinate will be in the form of x comma y comma z. Here there we were taking to the coordinate axis as a x-axis and y-axis in 2D geometry. Here we will be taking one more axis, that is x-axis, y-axis, and we can take z-axis like this. Okay, so this way here the coordinate will be in the format of x comma y comma z. Now here we can understand the 3D geometry in the pattern, like we are having one plane like this, then another plane is cutting it like this, and then one plane uh, is the visual representation. Let me show you the visual representation. Just give me a second. Can you see my screen? Here, this is the visual representation of the 3D planes. Okay, I am just zooming it on the right hand side of the screen. Here you can see the planes are cutting each other. These are the planes which are cutting each other, and this way we are getting x-axis, y-axis, z-axis. Here you can understand, like there we were having the quadrants, like in 2D we were having 4 quadrant. Here we are having octants. Okay, you can understand two floors are there, the upper floor and the downward floor, and in the downward floor there are 4 rooms. You can see 4 rooms are there in the downward floor and 4 rooms are there on the upward floor. So total 8 rooms are there. You can understand it like this. So 8 octants are there. Okay, when the planes are cutting, like just intersecting with each other, just getting cutted with each other like this. Okay, now we can say from here, we can say, let me write it on the screen. From here we can say 3 coordinate planes. The way you have, like the way it was drawn over there, that 3 coordinate planes divide the space into 8 parts. As I have explained, it is just dividing the space in 8 parts. For just, you can understand it like this, like four rooms are there in the base floor and 4 rooms are there on the top floor. So total 8 parts we are getting, and that is known as octants. Okay, now the next concept over here is, in 3D geometry we are having z-axis like this, y-axis, here x-axis, and if we are having a point P, the coordinate of point P in the form of like x comma y comma z. Okay, so here suppose the coordinate of point P is 5 comma 7 comma 8. Now from here O is the origin, so OP we can draw like this. Now in Cartesian form, the coordinate is in Cartesian form. The coordinate is 5, 7, 8. And in vector form, we can write the position vector of point P. Okay. So we can write it like 5i plus 7j plus 8k. Yeah. So this is how we can represent it in Cartesian form, and this way we can also represent it in vector form. I hope you have already like just the vector chapter is already clear to you. Then and only then you will be able to understand this chapter well. Okay. So let's move to the next concept. Now in 2D geometry, equation of line we used to find by using the equation y minus y1 is equals to y2 minus y1 by x2 minus x1 over multiplied with x minus x1. You can also write it as y minus y1 by, just a moment. Yeah. So this is how we used to write the equation of a line when we were talking about the 2D geometry. Okay. Now in 3D geometry, we will be writing the equation of a line like this. Just a moment. Suppose we are having the coordinate like this, and there is a point A, there is a point B, and if the coordinate of point A is 3, 5, the coordinate of point B is 9, 8, then we can write the equation of a line in Cartesian form. It was y minus y2 over x minus x2 is equals to y2 minus y1 by x2 minus x1. Do you know this formula? Do you know this formula? Have you seen this type of formula, the upper one or maybe the lower one? Please let me know. Yes, the upper one. The upper one, yes. So yes, that is the formula for writing the equation of a line. That is y minus y1 is equals to y2 minus y1 over, that is basically we are writing like y minus y1 is equals to m x minus x1, and the slope m we can also find it by using the formula of the slope, that is y2 minus y1 over x2 minus x1. So this way we used to write the equation of a line in 2D geometry. Now in 3D geometry we will be writing the equation of a line. Okay. In 2D geometry the vector form will look like, we can find the position vector of A like from origin, B from origin, let me draw it properly. This was in Cartesian form. For 2D geometry, we will be just coming to 3D also after this one. And this one for B. And in vector form, we can write it as, this is origin O. Here we are having OA, OB, and we need to find equation of a line AB. We can write it in vector form if you know the triangle law of vector. So we can write it as OA vector plus AB vector is equals to OB vector. Do you know this triangle law of vector? Please let me know. OA plus AB is equals to OB. How I am writing it, is it clear to you? Just look at the triangle. Can you see the triangle? OA plus AB is equals to OB. This, and then is equals to OB. It will not follow this direction, it will follow the reverse direction. Do you know this law? Have you seen this law in vector chapter? Yes or no? Anyone? You can also write it in the chat box. You don't know? Have you done no? Okay, vector chapter. Have you done vector chapter? Okay, no one knows this triangle law. Okay, let me explain this law at first. Just a moment. Triangle law of vector addition says,
triangle of Learnivio.
yeah,
Triangle of Learnivio.
yeah,
Triangle of Learnivio.
triangle law. You don't know?
Ma'am, he Prince teacher.
Oh, sorry, your voice is not clear. Yeah, you can tell me.
Sir already teached triangle law.
It is already like done in vector chapter, right?
Yes.
Yes. So that law only I am writing over here. Let me write it again properly so that you will be able to recall the concept. Okay. So the basically this law says that when two vectors are represented as two sides of a triangle. So if one of the side of triangle is like this and another side of the triangle is like this, okay? When two vectors are represented as a two side of a triangle, let's say this is vector A and this is vector B, okay? With the order of magnitude and direction. You can see the order of magnitude and direction is there. The direction is in order this way and this way. The arrow is moving first towards the right and then towards the up. It is continuing the pattern. Okay. Then the third side of a triangle represent the magnitude and the direction of the resultant vector. The third side of this triangle, this is the third side. This will represent the magnitude and the direction of the resultant vector. This is the resultant vector r. And the direction of this resultant vector, it will not follow the pattern. If you are having towards the right and then up, then it will be towards the like this direction. The arrow will be in this direction. It will not follow. It's not like that this way, then this way, and then this. Just a moment. I believe I have drawn it incorrectly. One of the side is like this, another side is like this, then the third side will not be like this. It will not be like this. Okay. It will be in the reverse direction. That means the direction of the resultant vector will be like this. If you can see the red arrow. Okay. It will be in the opposite direction. Similarly, I have written over here that is OA. You can see here also we are having a triangle. The triangle name of the triangle is OAB. Okay, let me draw it separately. Here we are having the triangle OA and B. Okay. This is how we are having our triangle over here. Now, just see the arrows. Here we are having arrow like this. Then here we are having arrow like this. So two side OA and AB. Can you see it is following the pattern OA plus AB will be equals to the resultant vector. Resultant will not follow the same pattern. It will not be like this, and then like this. It will not be like this. Okay, it will be in reverse direction. That means the arrow over here will be like this. You can see OB, arrow is like this. That's why OB we are taking as a resultant vector is equals to the other two vectors, that is OA plus AB. Is it clear? We are just using the triangle law. of addition of vector. Okay. So this is how we can write it in the vector form. The Cartesian form, equation of line you have seen over here. The vector form, this way we can write it. The equation of a line AB now can be written as AB can be written as OB, vector OB minus vector OA. Now vector OB, vector OA, we can find it. We can find over here vector OB. We can find here over here vector OA. How? Vector OB will be 9i plus 8z and OA will be 3i plus 5z. Okay, we can substitute it over here. That is 9i plus 8z minus 3i plus 5z is equals to, now we can open the bracket. So we will be having 9i minus 3i plus 8z minus 5z. So it will be 6i plus 3j. This is our equation of a line AB in vector form. Okay. Now we are talking about 3D geometry over here. This was all about 2D geometry. Now in 3D geometry, representation of a 3D line in Cartesian and vector form. So in vector form, let's start with vector form first. So in vector form, it will be like the previous one. Let's say here, the only difference will be here the coordinate will be in the 3D form, like x comma y comma z. So let's say we are having one point A. The coordinate of that is 3, 5, 2. And we are having the another point B. The coordinate of that point is 8, 7, 6. Now we have to find AB. Okay. We can join it like the previous one. So here is the origin O. We can find OA. Then we can find OB. So OA, OB, OB will be, OA will be 3i plus 5z plus 2k. OB will be 8i plus 7z plus 6k. Now, according to vector addition, what we can write? We can write it like the previous one, that is AB. This OA, let me write it properly without just skipping any part. So we can write it OA plus AB is equals to the resultant vector, that is OB. So basically AB will be OB minus OA, just like the previous one, and we can write it as OB. We have already found 8i plus 7z plus 6k minus OA, that is 3i plus 5z plus 2k. Now we can just open the bracket and we can do the calculation. So basically vector AB will be 8i minus 3i plus 7z minus 5z plus 6k minus 2k. We can write it as 5 plus 7 minus 5, 2z plus 4k. This is the equation of a line AB in vector form. Is it clear?
Yes.
Is it clear? Now,
Yes, sir.
okay. Now here we are having one concept that is direction cosine of a line. As the name says, direction cosine. So whenever we are talking about direction in mathematics, direction in vector chapter, that means we are talking about the angle, like what angle the line is making with x-axis, y-axis, z-axis. Okay, so direction cosine, cosine means cos theta, and direction means the angle. So direction cosine of a line, we can represent it as a cos alpha, cos beta, cos gamma, where alpha, beta, gamma are the angle with x-axis, y-axis and z-axis. Now only we will be using, here we are having, let's say this is z-axis, this is y-axis and this is x-axis. So with x-axis, suppose here we are having a straight line. Let me draw it. Suppose here we are having a straight line. This is our straight line. Now this straight line is making alpha with x-axis, beta angle with y-axis and gamma with z-axis. This is how this line is having the direction with respect to x-axis, y-axis and z-axis. And while writing the direction cosine of any line, what we write, it is nothing but just the cos alpha, cos beta, cos gamma, where alpha, beta, gamma are the angle the line is making with x-axis, y-axis and z-axis. Now there is a relation. We also represent this cos alpha as L, this cos beta as a M, and this cos gamma as a N. And there is one relation in between this cos alpha, cos beta, cos gamma, or we can say there is one relation between this L, M, and N. That is L square plus M square plus N square is equals to 1. Now on the basis of this concept, we will be solving few questions. Let's solve those questions, then we will be just moving ahead with the next concept. So the first question is, if a line makes angle 90 degree, 60 degree and 30 degree with the positive direction of x, y and z axis respectively, find its direction cosine. Angle is given, we have to find the direction cosine. Now only we have discussed direction cosine, just the word is looking so what exactly it is. But direction cosine is nothing but cos alpha, cos beta, cos gamma, where alpha, beta, gamma are the angle made with the x-axis, positive direction of x-axis, y-axis and z-axis. So basically, if we have to find the direction cosine in this question, what we will be finding, directly we can find cos of alpha. Alpha value is given over here as a 90 degree, beta value is given over here as a 60 degree and gamma value is given over here as a 30 degree. As you can see in the question itself, 90 degree, 60 degree and 30 degree. We just have to find the direction cosine. Cosine means sine, cosine, tan theta, cot theta. So you know cosine means cos theta. So cos alpha we have to find, that is cos 90 degree we will be finding. Then we will be finding cos beta, that means cos 60 degree, and then cos gamma, that is cos 30 degree. Now we will be telling what is the value of cos 90 degree, cos 60 degree and cos 30 degree. Please reply Either you can unmute yourself and you can answer it, or you can write it in the chat box. The value of cos 90, cos 60,
0,
cos 30. Yeah, cos 90 is
0,
0. Cos 60,
1/2,
yeah, yeah, perfect. And cos 30
root 3/2.
is root 3 by 2, perfect. So this is how we got the direction cosine according to the given angle. Yes, yes, perfect. Let's move ahead. Okay, now we will be discussing about direction ratio of a line. So direction ratio of any line, let's say we are having the coordinate plane like this. If there is a line OP, then OP, let's say in vector form, it is AI plus VJ plus CK. Here A, B and C, this coefficient is called the direction ratio. A, B and C are direction ratio over here. And there is one relation between direction ratio and direction cosine. What is that relation? Let me write it. The relation is L is equals to A over under root A square plus B square plus C square. M is equals to B over under root A square plus B square plus C square. This is the relation between direction ratio and direction cosine. What is direction ratio? Whenever we are having an equation of a line in vector form, then the coefficient A, B, C, these are the direction ratio. Okay. N is equals to C over under root A square plus B square plus C square. Now here we are having one question which is related to this concept. So the question says, if a line has direction ratio 2, -1, -2, determine its direction cosine. Direction ratio is given. We have to find the direction cosine. Direction cosine means cos alpha, cos beta, cos gamma, which can also be written as a L, M, N. So basically, direction cosine, whenever it is asking, either we will think about finding cos alpha, cos beta, cos gamma, or we will think about finding L, M, N if there is any relation related to that. So here, just above this question, you can see there is one relation which I have written, that L can be found like this, M can be written like this. This is the relation, and N can be written like this. L, M, N are direction cosine. Okay. So here we have to find direction cosine. Okay. Determine its direction cosine. So we have to find L, we have to find M, we have to find N. Okay. How we will be finding L, M, N? So if a line has a direction ratio is given 2, -1, -2. This is A value, this is B value, this is C value. If we know A, B, C, then we can use the above formula to find the direction cosine, that is L, M, N. Let's use the above formula which I have just written in the rectangular box. So it will be, the formula says it is A over under root A square plus B square plus C square. What is our A? A is 2. 2 over A square, that is 2 square 4, plus B square, that is -1 square 1, plus C square, that is -2 square, that is 4. Okay. If we will do the calculation, we will be getting 2 over 44819. So root 9, which will be 2 by 3, right? Similarly, here we will be having b over the same thing, root a square b square c square. Now our b value is -1 and the denominator, now only we have done the calculation, that is 3. Now c over c is -2 and the denominator, now only we have done the calculation. This is the denominator and the same denominator I am going to write it over here because all the formulas are same. You can see in each and every formula the denominator part is exactly same. So whatever I have calculated for the first one, I am going to use it for the second and the third one. So what we got, L as a 2 over 3, M as a -1 over 3 and N as a -2 over 3. This one, this is the direction cosine. This is the result, like this is the answer for the direction cosine. Okay. Now another question is, just a moment. Okay. So the next question is, find the direction cosine of the sides of the triangle whose vertices are 3, 5, -4, -1, 1, 2 and -5, -5, -2. So we have to find the direction cosine of the side of a triangle whose vertices are given over here. Let's draw a triangle. So we are having a triangle. Let's say the name of the triangle is ABC. ABC. Here, one of the vertex is given as a 3, 5, -4. Another vertex is given as a -1, 1, 2. The third one is given as a -5, -5, -2. Now, if we want to write side AB, and if there is a like origin O, the coordinate plane is like that, x axis, y axis, z axis is just like the previous one, then in vector form how we were writing AB, just let's recall. Now only we have written in vector form. See, AB we have got as a OB minus OE, okay, by vector law of addition. In the vector form, for three-dimensional, for 2D geometry, for 3D, for both, we have got AB as a OB minus OA. Okay, so here rather than drawing the origin O, the x-axis, y-axis, z-axis, directly I am going to write AB as a OB minus OA. Okay, let's write it. We can write the equation of a line AB in vector form as a OB minus OA. Any confusion over here? Directly I am writing it. Okay. Now what will be OB? Here -1i plus 1j plus 2k. What will be OA? That will be 3i plus 5j minus 4k. Right? Let's write it. So OB, that is -1i or -i directly you can write, plus 1j. If you want to write 1, you can write, otherwise you can skip writing 1 in the front. minus OA will be 3I plus 5Z minus 4K. Equation of a line AB in vector form, we are writing it, nothing else. Okay, let's do the solution. So we will be having negative 1I minus 3I. It will be minus 4I. 1J is here and minus 5J. That means minus 4J plus 2K plus 4K plus 6K. Okay. So this is what we got the equation of a line AB. Let me match it. Yeah. Now here, now only we have discussed direction ratio. What is the meaning of direction ratio? Whenever we are having the equation of a line in vector form, this is the direction ratio. This one is this one, and this one is the direction ratio. Now only we have discussed. See, direction ratio means nothing but just this A, B, C. This A, B, C are the direction ratio. Okay, so that's why we have written the equation of a line AB, one of the side of our triangle. First we have written the equation of that side, the equation of that line in vector form, so that we will be getting the direction ratio. Okay, now we got the direction ratio over here, that is negative 4, negative 4 and 6. This is our A value, this is our B value, this is our C value. Now let's see what we have to find over here. So find the direction cosine. Direction cosine, whenever it says to find direction cosine, we have to find cos alpha, cos beta, cos gamma, or if there is any relation related to L, cos alpha means L, cos beta M, cos gamma N. So we are having one relation which is related to L, M, N and A, B, C, the direction ratio. What is that relation? You can see the relation over here. This is the relation. This one. LMN we can find by using ABC. Okay, so this relation we will be using to find L, M and N. Let's do that. So L will be A over under root A square plus B square plus C square. ABC value you can see I have written just above it. M value we can get, what are we doing? We are finding the direction cosine by using the direction ratio. Okay, how we got the direction ratio? By finding the equation of a line. Okay, B over under root A square plus B square plus C square, and N will be C over under root A square plus B square plus C square. This way we will be getting the direction cosine of one of the side of the triangle. Similarly, we have to find the direction cosine of each and every side. Let's get back to the question. Find the direction cosine of the sides of a triangle. Direction cosine we have to find of each and every side of the triangle. So what we did, let me summarize it. We are having a triangle like this. The vertex coordinate we know over here, the vertex coordinate we know over here, the vertex coordinate we know over here. 3, 5, 4. Let me write it. 3, 5, negative 4. Then minus 1, 1, 2. And here we were having minus 5, minus 5, minus 2. Minus 5, minus 5, minus 2. So basically we are having a triangle like this. We have to find the direction cosine of each and every side. So first we have found the direction cosine of the side AB. How we will be finding the direction cosine of side AB or the line AB? So first we have written the equation of a line AB in vector form. Okay, that was very simple to write the equation of a line in vector form by using triangle law of addition. Okay, AB is equals to OB minus OA. We got the equation of a line AB in vector form. Why we did so? So that we can get the direction ratio, that is ABC. Once we got the direction ratio, then we have written the direction cosine by using one of the formula which we are having in hand. Similarly, we will be finding the equation of a line AC and the equation of a line BC in vector form first. Okay, So what will be the next step? The next step will be finding the equation of a line AC in vector form by doing OC minus OA. How are we writing this one? We are using the vector law of addition. Okay, we can write the equation of a line by using the coordinates and everything. OC, we can write it over here. OC will be minus 5I minus 5J minus 2K. OA will be 3I plus 5J minus 4K. This way we will be finding OC, OA. Then we will do the subtraction and we will get the equation of a line AC in vector form. Once we will get that, then we will be getting A, B, C value. Let's do this one. The third one I'll be leaving for you. So OC, here I have written that is minus 5I minus 5J minus 2K. OA will be 3I plus 5J minus 4K. Let's do the subtraction directly and quickly. Minus 5I minus 3I, 8I minus 5J. Here we are having minus 5J minus 10J minus 2K, and here we are having plus 4K, 4, 5, 6 plus 6K. So this is our equation of a line AC in vector form. Why with it so? So that we will be getting this one. A value, B value, C value, that is called the direction ratio. So direction ratio over here is minus 8, minus 10 and 6. This is our A value, this is our B value, this is our C value. We wanted to find ABC? No, our main focus is to find L and N. That is direction cosine, and the formula for that is A over under root A square plus B square plus C square. M is equals to B over under root A square plus B square plus C square, and N is equals to C over under root A square plus B square plus C square. Now we just need to put the value and we need to find the L, M, N value. Let's do it quickly. One calculation we will be doing for L and directly we will be getting M and N. So here we are having negative 8 over A square, that is negative 8 is square 64, B square that means 100, and C square that means 36. So 64 plus 36, 100 plus 100, 200. So minus 8 by 200 I can see root. We got over here. M will be negative 10 by root 200 and N will be 6 over root 200. We got the direction ratio. Direction cosine. This is our L value. This is M and this is N, and that's what we wanted to find for each and every side of the triangle. This we have done for the second side, that is AC. We also need to do the same thing, the whole process for the side BC. Okay, first we will be writing it, the equation of a line BC in vector form, that is OC minus OB, and then we will be finding the direction ratio, and then we will be finding the direction cosine. Is it clear to each and every one over here? Please let me know.
Yes.
Clear?
Yes, sir.
Yes. Okay. Okay, let's move to the next concept. Now there is a concept which is related to equation of a line through a given point and parallel to a given vector B. So equation of a line, first we will see the formula, then we will solve few question related to it. So suppose we are having the coordinate plane, that is Z, Y, X. Now equation of a line through a given point, suppose we are having a straight line like this, a line L through a point A, okay, and parallel to a given vector. This line is parallel to this vector B, okay. Here the position vector of this is A. There is a random point P on it, and that's position vector is R, let's say. So the equation of the line will be lambda B is equals to R minus A, okay, where B is the parallel line, R is representing any random point, P is there on our line L, that's position vector, and A is the point A, that's position vector, okay. Now this is the formula. How we will be using this formula? Just a moment, let me take a question. Okay. So the question is, find the equation of the line which passes through the point 1, 2, 3 and is parallel to vector 3i plus 2j minus 2k. Okay, so before this we need to discuss one more formula, then only you will be able to solve this question. So basically we can take it like this. We will get back to this question. Before this you need to understand that if we are having z-axis, y-axis, x-axis, and if there is a point A, okay, let me write it over here only to just give the brief explanation. Here let's say the coordinate of point A is x1, y1, z1, let's say, okay, and this is B, that is okay. Here we are having the origin O. So now let's say B can be written as, we are assuming it, that B can be written as AI plus BZ plus CK. Okay, A, B, C are the direction ratio over here. A can be written as X1I plus Y1J plus Z1K. And this R, let's say this coordinate is XYZ only. So let's say this R can be written as XI plus YZ plus ZK. Now we will be substituting everything in this formula and we will be getting one relation. Just a moment, no? Okay, already we are running out of time. We will be continuing from here. from the very beginning. From this concept we will be starting in the next class. Okay, you just need to do all the question which is related to direction ratio and direction cosine. We will be starting with this new formula and new thing in the next class. Okay, is it okay? Is
Yeah.
it okay? Okay. Okay, then I am keeping it this much. If you want to ask anything from here, please ask.